Hello, so this is Ken Church, and I'll be presenting our paper. So this is a survey or position paper, and what do we need to do to improve coverage of WordNet? Do we want to collect more data, or do we want to use knowledge graph completion? So the data collection discussion will start with a discussion of quantity versus quality, how much do we need, and there's a lot of history here. There are two problems with the alternative view, the knowledge graph completion. One is leakage. Some of this is known and some has not been known. And the other one, which is probably more serious, is the size. Our recommendation is that we should collect more data and stop a lot of the distraction with flawed benchmarks. So let's talk about quantity versus quality. A balanced corpus, say the brown corpus, was intended to be a sample of something, and it was a sample of 1 million words, which is small by modern standards. Many of the modern corpora, say the Penn Tree Bank and SemCor, which is the basis of WordNet, are based on top of this. There's some other balanced corpora that are somewhat more recent and somewhat larger, but they're still small by modern standards. Now, the alternative view is catch as catch can, and this is what we currently do for most of our. Now, Mercer was really a strong advocate of what we do today, but in fact, there's much to be said for the lexicographer's position. It's just not heard very much now. Now, Rapp did some very interesting work which compared statistics based on balanced and unbalanced corpora with various psycholinguistic norms. And in this way, we can make statements about the value. So he looked at 2 balanced corpora and 3 unbalanced corpora. And based on his work, we can come away with 2 very simple rules of thumb. One is balancing. The balance trade-off. Balancing is worth about 2 orders of magnitude, so that if you use a balanced corpus, work with about 100 times less data than if you use unbalanced corpora. And the second one is that first-order statistics, that is, associations of single words and psycholinguistic norms, are just a lot easier than second-order associations. The second-order associations are going to require at least 100 times more data, and it's sort of unimaginable that you could do anything with 1 million words. And that would be that it's sort of unimaginable that you could do anything like the Brown or Penn Tree Bank or SemCor that's going to tell us much of anything about second-order associations, edges in WordNet. And so if we want to discuss edges in WordNet, we're really going to need 100 times more data and something much bigger than the Brown corpus. Now, knowledge graph completion is an alternative. They don't worry about any of these sizes. We just start with a very simple graph based on WordNet. We've got some vertices, the WordNet synsets. You have some edges, which are relations on the synsets, and you split the edges into test, train, and validation in the obvious way. You train a model on the training set, and then you predict on the held-out test set. We may notice that these relations come in pairs. So in this benchmark WN18, they used 18 relations from WordNet, and it turns out that many of these relations are there implicitly in 2 ways. So if X is a Y, then there'll be a hypernym link in one direction, a hyponym link in the other direction, and the counts are pretty much the same, almost by construction. Now there's 2 obvious problems with this. One is leakage and the other is size. Some of this was previously reported. When they realized that these edges were duplicated in this way, they removed the ones on the right and reduced the WN18 benchmark to a WN18RR. And the WN18RR has only 11 relations as opposed to 18. Now, that's fine, but it turns out there's more that's not been previously reported. So let's look at the dominant case of derivationally related forms. There's almost 32,000 edges like this, and these also come in pairs, but in this case they're both spelled the same way. They're both derivationally related forms. So if X is derivationally related to y, then y is derivationally related to x by construction. And this creates another opportunity for leakage. And what we observe here is that of the 1,074 edges in the test set that are in this relation, all but 24 are in either train or valid in the other direction. And so by these means, you can trivially get 98% right without actually learning anything at all interesting, just by exploiting this flaw in the benchmark. And this leakage is caused by a failure to appreciate the conventions in WordNet, and that the WordNet relations are represented with pairs of edges, not single edges. Now, the size problem is probably even more serious than the leakage problem. That, as we reported before from Rapp's numbers, that SemCor is based on Brown corpus, and SemCor is only 20% of Brown corpus. It's only 200,000 words. It's way too small to see second order relations. That would be things like edges in WordNet. A small corpus is kind of like downsampling in speech. So it's easy to go from 16 kilohertz speech to 8 kilohertz speech, but it's very hard to go in the reverse direction, go from 8 kilohertz speech to 16 kilohertz speech. That is, after you've thrown away the high frequencies, they're really hard to recover. A small corpus is like a downsampled corpus. Once you've thrown away the information by using a small sample, it's very, very difficult to recover the information that just isn't there. And knowledge graph completion is trying to do this kind of upsampling. It's just not a very sensible exercise. And so in conclusion, we offer here a survey or position paper. What do we need to improve coverage? We suggest you should collect more data and stop the knowledge graph completion work. You're just not going to find edges that are just not there. There's two problems with the knowledge graph completion work. First is that it's just flawed. There's information leakage. Some has been reported, some not. And then more seriously, there's the size problem, that based on Rapp's estimates, you're going to need more data than what is behind WordNet. And that knowledge graph completion is not going to recover information that's not there. So the recommendation is that data collection is good, and that knowledge graph completion on flawed benchmarks is not good. And more seriously, what we're worried about is that all of this emphasis on knowledge graph completion has been sucking the oxygen out of the room. That flawed benchmarks have been distracting us from doing the hard work that we need to do, which is collect more data. Thank you.